The sun has been a prime area of energy for us, particularly of past due, and it will undergo an important, also enamoring exchange, the reversal of its magnetic area. This attachment happens, for the most component, at standard reaches. That means the midpoint of the sun cycle, and it has far-achieving repercussions for us right here on the planet. Accept as true with it or now not, it's viable that, rapidly, the solar should gift a severe chance that could cause complete disruption and disaster for anybody on Earth. As you will find, the solar's magnetic field is created via the motion of electrically charged gases in its indoors, a system referred to as the sun dynamo. Over the long haul, this magnetic area becomes increasingly complicated and reshaped due to the solar's transformation and convective changes. Sooner or later, this cycle ends in a complete reversal of the magnetic poles. The north magnetic pole adjustments into the south magnetic pole and vice versa. So, could we damage down the whole cycle and take a greater accrued have a look at the sun? The sun is made commonly out of hydrogen and helium as plasma, a kingdom of matter where electrons aren't certain to particles, ensuing in a mixture of unfastened electrons and ions. The sun's indoors is divided into numerous layers, with the center encased by way of the radiative region and the convective quarter. The center is the sun's maximum full-size region, in which nuclear fusion occurs, converting hydrogen into helium and liberating sizable amounts of power. Above the middle lies the radiative area, wherein electricity is transferred outward via radiation. In this area, power actions slowly outward as photons are absorbed and re-emitted by means of the solar plasma. The outer layer of the solar's interior is the convective quarter, in which power is transported via convection. Warm plasma rises toward the floor, cools, and sinks once more, creating convective currents. The sun dynamo system works fundamentally in the convective sector and the tachocline, a skinny layer that lies between the radiative region and the convective area. The tachocline is critical because it's where the solar's differential rotation and shear flows play an important function in growing the magnetic discipline. Now, here's something exciting that you in all likelihood haven't heard. The solar doesn't rotate as a strong frame. Instead, unique components of the sun rotate at extraordinary fees, with the equator rotating faster than the poles, a phenomenon referred to as differential rotation. This differential rotation stretches and twists the magnetic subject lines, elongating the magnetic subject. The solar cycle is an approximately 11 to 12-month cycle, during which the solar's magnetic field undergoes a series of modifications, culminating in a reversal of its poles. This cycle is pushed through the solar dynamo and entails several tiers. At the beginning of the solar cycle, the sun is in a state known as sun minimum, characterized by a low variety of sunspots and minimum solar activity. The magnetic field is commonly easy and bipolar, with a clean north and south magnetic pole. As the cycle progresses, the number of sunspots will increase. Sunspots are areas of extreme magnetic activity and are associated with the upward thrust of magnetic hobby from the sun's interior. Those sunspots seem in pairs with opposite magnetic polarities and migrate in the direction of the equator through the years. Around the midpoint of the sun cycle, the sun reaches solar maximum, a period of top pastime with the greatest wide variety of sunspots, solar flares, and coronal mass ejections, CMEs. The magnetic area will become extremely complex and tangled because of the non-stop twisting and shearing with the aid of differential rotation and convection. As solar maximum fades, the magnetic area starts off-evolved to reconfigure itself. The reshaped and tangled magnetic field strains reconnect, and the global magnetic field step by step reverses its polarity. The north magnetic pole becomes the south magnetic pole and vice versa. This cycle is facilitated by using the advance and restructuring of solar plasma movement areas. After the pole reversal, the sun enters a duration of declining pastime, returning to solar minimal. Finally, the magnetic subject reconfigures, and the cycle is prepared to begin anew. At gift, we're inside the sun most degree, and the solar's magnetic area is ready to flip. At some stage in this level, we can assume to peer a few activity from the sun that would be as risky as it's far charming. But the solar's magnetic field reversal isn't an unexpected turn, however, as a substitute a continuous cycle. As the solar cycle advances, the solar's magnetic field undergoes a sequence of changes. At the moment, the magnetic discipline is at its maximum twisted and tangled state. It reaches a tipping point and starts off-evolved to reorganize itself, resulting in a turn. So, can we know whilst the solar's magnetic discipline will turn? Scientists monitor the solar's magnetic interest using numerous devices and strategies. Observatories equipped with effective telescopes, each on the Earth and in space, provide detailed images of the solar's surface and its sunspots. Devices like the Sun and Heliospheric Observatory and the Solar Dynamics Observatory degree the solar's magnetic subject and its adjustments through the years. One key indicator of a forthcoming magnetic reversal is the behavior of sunspots. At some point of solar maximum, sunspots seem greater regularly and become more stated as they pass toward the solar's equator, a sign that the magnetic discipline is becoming greater unstable and is making ready to turn. Whilst we're on the issue, permits dive a little deeper into sunspots. While the solar's magnetic discipline traces grow to be twisted and tangled due to differential rotation, the solar's equator rotates faster than its poles, inflicting the magnetic lines to stretch and bend. When those lines loop over the sun's surface, they suppress the convective movement of warm plasma from the solar's indoors, resulting inside the cooler, darker patches we see in sunspot pictures. Sunspots aren't best charming solar features. However, they could on occasion produce effective solar flares and coronal mass ejections, CMEs. These phenomena launch significant amounts of electricity and charged particles into space. Whilst directed in the direction of Earth, they can disrupt satellite communications, have an effect on power grids, and pose threats to astronauts in area. Moreover, extended solar activity can decorate auroras. However, it could additionally improve radiation tiers in Earth's top surroundings. So, whilst we're on the topic, let's have a look at the distinction among sun flares and coronal mass ejections, CMEs. While both are large outbursts of power from the solar, they differ notably. Solar flares are sudden, extreme bursts of radiation caused by the release of magnetic power related to sunspots. They launch a first-rate amount of energy and light, frequently in the shape of X-rays and ultraviolet radiation. Consider them as bursts of vivid mild and heat on the solar's surface, like a large explosion. In contrast, CMEs are large releases of solar wind and magnetic fields from the sun corona. They can be notion of as large bubbles of fuel and magnetic fields being expelled into space. Whilst a coronal mass ejection occurs, it sends billions of lots of solar particles into area at extremely high speeds. So, while sun flares and CMEs are associated, they are no longer the same. A solar flare can occur independently. However, on occasion, an exceedingly powerful solar flare may be followed with the aid of a CME. Although a solar flare does not necessarily reason a CME, they may be linked in phrases of hazard. Solar flares can disrupt radio communications and navigation indicators, posing an enormous hazard to astronauts in space due to the acute radiation. However, CMEs may have a broader impact. CMEs can motive geomagnetic storms that disrupt energy grids, satellite operations, and navigation systems. They also can decorate auroras but pose severe risks to Earth's era and infrastructure. Some other consideration is that in times of excessive sun interest, the amount of high radiation reaching Earth also increases. Satellites and different space automobiles are especially liable to extended solar interest. The charged debris from the sun can harm electronic additives, disrupt conversation indicators, and even regulate satellite TV for PC orbits. Beyond causing harm to era and infrastructure, what else can manifest to the planet? Whilst the sun's magnetic subject reversal doesn't without delay affect Earth's surroundings, the related adjustments in solar interest can have an effect. A few research suggests that versions in sun radiation can impact atmospheric situations and weather patterns. As an instance, expanded solar interest can cause a mild warming of Earth's ecosystem, probably fueling existing climate alternate. Would possibly auroras be the handiest high-quality issue we enjoy right here on Earth? Possibly one of the most putting results of accelerated solar activity is the enhancement of these surprising lighting fixtures. These natural mild shows, known as the northern and southern lights, arise while charged particles from the solar interact with Earth's magnetic area and environment. We often hear approximately the aurora borealis. However, these lights also can be visible around the South Pole. At some stage in times of excessive sun interest, auroras emerge as more frequent and can be visible at lower latitudes, imparting dramatic nighttime displays. However, except the stunning auroras, there also are more regarding elements of the solar's magnetic reversal that would occur if we are unprepared. One of the primary threats associated with a magnetic subject reversal is the expanded probability of geomagnetic storms. Those storms occur while sun wind, overloaded with charged particles, interacts with Earth's magnetic discipline. In intense cases, they can cause good-sized blackouts and harm to infrastructure. One such event took place at the morning of September 1, 1859. Astronomer Richard Carrington began observing the sun through his telescope as he had achieved commonly before. However, what he saw on this specific day could stand out in records because the first recorded solar hurricane. At 11:18 a.m., Carrington noticed a bright flare of white light emanating from a collection of sunspots. This event, now referred to as the Carrington event, marked the start of the most important geomagnetic storm ever recorded. The white light Carrington saw turned into an enlarged solar flare, an excessive burst of radiation caused by the discharge of magnetic strength stored within the sun's surroundings. This flare turned into so powerful that it prompted a huge coronal mass ejection, CME, directed in the direction of Earth. The CME reached Earth in just 17.6 hours. A remarkably brief time thinking about the sun is 93 million miles away. Whilst the CME hit Earth's magnetosphere, it induced an exceedingly sturdy geomagnetic storm. The impact became brief and giant, stressful Earth's magnetic field and inducing currents inside the ground. Furthermore, telegraph lines, which were the backbone of world communique at the time, experienced extreme disturbances. Sparks flew from telegraph machines, operators received electric-powered shocks, and some message stations even burst into flames. The induced currents have been so strong that operators should send and receive messages even after disconnecting their batteries. One of the maximum putting and significant outcomes of the Carrington occasion was the extremely good display of auroras. The auroras were so bright and big that they were seen a ways beyond the typical polar areas. Humans as a ways south as the Caribbean, Mexico, and Hawaii suggested seeing the sky illuminated with vibrant hues. The auroras were so excessive that they lit up the nighttime sky, permitting humans inside the northeastern U.S. to read newspapers via their light. Within the Rocky Mountains, gold miners have been reportedly awakened by the brightness, mistaking it for dawn and beginning to put together breakfast. Humans define the sky as having sparkling purple, inexperienced, and pink colors transferring and shimmering across the horizon. Now believe if a solar hurricane of the magnitude of the Carrington occasion had been to hit Earth nowadays, the results would be catastrophic. The solar is undergoing a massive transformation. The reversal of its magnetic field, a manner that takes place roughly every 11 years as part of the solar cycle. This occasion, driven by using the sun dynamo, ought to have a ways accomplishing consequences for Earth, probably inflicting disruption and catastrophe. The solar's magnetic discipline is generated by means of the motion of electrically charged gases in its interior, developing a complex magnetic subject that ultimately reverses its polarity. The sun is often made of hydrogen and helium plasma, with strength produced by way of nuclear fusion in its middle. This strength is transferred outward through the radiative region, after which via convection within the outer layers. The sun dynamo machine, which operates within the convective region and the tachocline, generates the solar's magnetic area. Differential rotation of the sun, wherein the equator rotates faster than the poles, stretches and amplifies the magnetic field lines, driving the sun cycle. At present, the sun is inside the sun maximum level, where sunspots and solar activity are at their height, probably inflicting dangers like solar flares and CMEs that could disrupt satellite communications, strength grids, and pose threats to astronauts. Scientists reveal the solar's magnetic interest and sunspot conduct to are expecting when magnetic area reversals will arise. Sunspots, which result from tangled magnetic traces, can produce sun flares and CMEs, each massive releases of strength that have an effect on Earth in numerous ways. Even as sun flares emit radiation, CMEs eject big amounts of sun debris into area. These phenomena can decorate auroras but additionally pose critical risks to Earth's technology and infrastructure. The sun's conduct is a charming interplay of physics and natural phenomena, affecting no longer only our sun system but also lifestyles in the world. Understanding the complexities of solar activity is vital, especially as we hold to depend upon era that may be impacted via solar occasions. The solar generates strength through nuclear fusion, changing hydrogen into helium and generating full-size quantities of power within the procedure. This power travels through the diverse layers of the sun, finally accomplishing the floor and radiating into area. Solar interest can occur in lots of paperwork, including sunspots, sun flares, and coronal mass ejections. Sunspots are cooler regions at the sun's surface as a result of magnetic pastime, acting as dark spots. Those changes in solar interest observe an approximately 11-12-month cycle referred to as the solar cycle, in which intervals of excessive hobby, sun maximum, are followed through calmer durations, solar minimal. In the course of solar most, the quantity of sunspots will increase, leading to more frequent sun flares and CMEs. Sun flares are surprising outbursts of power that launch radiation across the electromagnetic spectrum, which includes X-rays and ultraviolet light. These excessive bursts can affect radio communications and pose dangers to astronauts in area. CMEs, then again, are giant eruptions of sun wind and magnetic fields that upward thrust from the sun corona and are released into area. While directed toward Earth, those ejections can purpose geomagnetic storms that disrupt the planet's magnetic subject, main to lovely auroras but additionally capability interruptions to technology. The results of solar activity make bigger past area. They influence Earth's ecosystem and surface. Research proposed that versions in solar radiation can have an effect on weather styles, doubtlessly contributing to climate anomalies. Extended solar hobby also can lead to atmospheric warming. That is an essential issue in discussions approximately weather exchange. Additionally, the potential for technological disruption due to solar storms cannot be understated. Extreme geomagnetic typhoon should damage electric grids, disrupt satellite TV for PC operations, and have an effect on navigation systems. Making ready for such occasions includes tracking solar interest and developing techniques to mitigate their effect on infrastructure. Researchers continue to observe the sun's magnetic field and its cycles to higher expect while tremendous sun events may additionally arise. This studies includes an aggregate of floor-based and area-based observatories that tune sunspots, degree magnetic fields, and examine sun wind. With advancing era, our capacity to predict sun hobby improves, which is critical for shielding our technological structures and making sure the safety of astronauts as we explore area. As we examine the solar, its effect on Earth becomes increasingly clear. From the stunning displays of auroras to the capacity-demanding situations posed with the aid of solar storms, the solar stays an effective force in our solar gadget. Knowledge its cycles and behaviors no longer best advances our knowledge of area technological know-how but additionally complements our preparedness for the impacts of sun hobby on present-day life.